A driver records the distance traveled in each of 150 journeys. The distances correct to the nearest kilometer are summarized in the following table. Part A, draw cumulative frequency graph to illustrate the data. All right, so the first problem we see in the given frequency table is that we have discontinuity in the data. There's 4 and then there's 5. So we need to bridge this gap. How do we do that? We add zero point 0.5 to 4 and we subtract zero point 0.5 from 5. So that way we'll get 0, then 4.5, and here we'll have 4.5 again. 10 will get 0.5 added to it. It will become 10.5. 11 will get 0.5 subtracted from it, and it'll become 10.5 as well. So that way we will be able to bridge the gaps, and this process is called continuity correction. So first thing, we apply continuity correction. So we write 0 to 4.5, then 4.5 to 10.5. Okay, 0 cannot change to negative 0.5. That's why we leave it as it is. Then we'll have 10.5 to 20.5, then 20.5 to 30.5. Similarly, 30.5 to 40.5, and lastly, 40.5 to 60.5. Okay, now when we change this frequency table, we'll have 12, 16, 32, 66, 20, and 4 here. Okay, change this frequency table into cumulative frequency table. Okay, so we write less than and equals to 0 will just be 0, less than and equals to 4.5 will be 12, less than and equals to 10.5 will be 16 plus 12, which is going to be 28, then less than and equals to 20.5 will be 60, less than and equals to 30.5 will be 120. How am I getting 120? By adding all of these. Then less than and equals to 40.5 is 146, add all the frequencies, and less than and equals to 60.5 will be 150. This value here should be equals to this value here, showing us that we got the table right. Now we're going to plot 0, 0, 4.5, 12, 10.5, 28, and so on till 60.5, 150 on the axis provided. We will first need to choose an appropriate scale. The x value needs to go from 0 to 60.5, and the y values need to go from 0 to 150. I am going to paste the plotted cumulative frequency curve, and then we'll go over that from there. Okay, so here's the curve completely drawn. Okay, so what scale did I choose? Started from 0, then I marked 5.5 because every value is in the range of 0.5, then 10.5, then 20.5. This was 4.5. So we start from 0, then 5.5, 10.5, 15.5, 20.5, all the way till 60.5. And the cumulative frequency starts from 0, then 1 centimeter is 10, then 20, then 30, then 40, all the way till 150. Please remember you're supposed to properly label the x and y axis. So distance in kilometers and cumulative frequency for the y axis. All right. Now the next part is for 30% of the journey, the distance traveled is d kilometer or more. I'm going to highlight this more. Okay, for 30% of these journey, in total there are 150 journey. Let's find 30% of 150. That's going to be 45. So they're talking about 45 journeys. So for 45 of the journey, the distance traveled is d kilometers or more. Use the graph to estimate the value of t. When they say more, what you'll do is you'll subtract the 45 that we just got from the total frequency, which is 150. So that gives 105. Now 105 is the y-axis value. From this, look at the red line. Read 105 on the y-axis and then read the corresponding x value of the curve that you get there. So I am roughly getting 27. So 27 or 27.5 would be the correct answer, whatever you're getting according to your own curve. So I'm writing 27 here. If the question had not used the word more but less, then what we would have done, we wouldn't have subtracted 150 from 45. We would have just read the value of the x value corresponding to 45. But when it says more, you have to first subtract 45 from the highest y value, which is 150, and then find the x value. Okay. Part C, calculate an estimate of the mean distance traveled for 150 journeys. Okay, for mean, we go back to the frequency table on which we applied continuity correction. This is the frequency table. Let me write 40.5 to 60.5 here and rub this. Okay, so now we have a frequency table and we have to find the mean. First value was from 0 to 4.5. And this was 12. Let me fix that quickly. This is 12. Okay, so for mean, you have to find the mid value times frequency plus next mid value times frequency and so on divided by total frequency. So what's the mid value of 0 and 4.5? It's 2.25. So find the middle of these two, 2.25 into 12 plus what's the middle of these two? Add them, divide it with 2. We will get 7.5 into 16 plus 15.5 into 32 plus 25.5 into 66 plus 35.5 into 20 plus 50.5 into 4 divided by total frequency, which is 150. It's given in the question as well, or you could add these up and you get 150. This gives us, I'm writing the rounded answer, 21.6, correct to 3 significant figures. There are 5,000 schools in a certain country. The cumulative frequency table shows the number of pupils in a school and the corresponding number of schools. Draw a cumulative frequency graph using the given scale. Okay, now also it says use your graph to estimate median number of pupils in a school. Okay, now it will be a very, very bad idea to just use this table and start plotting the cumulative frequency curve. The reason for that is that we need to realize that this data is discrete data. It shows the number of pupils in the school. These are discrete values. That means if I change this into a frequency table first, I'll start with 1 because the smallest number of pupil in a school can be 1. It cannot be 0. Okay, and then from 1, we can go till 100 because it says 100 over here. For the next group, you can't start with 100 because this is discrete data. You will start with 101. And the next group goes from 101 to 150. So 150. Next one starts from 151. So we notice that we have gaps in the data. So we need to apply continuity correction first, like the previous question. The next one will be 151, 200, then 201 till 250, then 251 till 350, then 351 till 450, and then 451 till 600. Okay, so when we'll apply continuity correction, we'll subtract zero point 0.5 from the previous value. This time we have 1 here and not 0, so we will subtract 0 0.5 from here and add 0 0.5 here. So we'll get 0 0.5 till 100.5, 100 and 100.5 till 150.5 and so on. 150.5 till 200.5. So that way the gaps in the data are bridged and we've applied continuity correction. Okay, now you can make a new cumulative frequency table where we will start with less than and equals to 0 0.5 would be 0, then less than and equals to 100.5 would be this 200, then less than and equals to 150.5 would be 800. So notice all you need to do is add a 0.5 here. So add a 0.5 here, a 0.5 here, all the way till end. And the first value is going to be 0 0.5. So you can add 0 0.5 and a 0 here. Okay, so now we're given the scale. On the x-axis, 2 centimeter is 100 pupil, and on the y-axis, 2 centimeter is 1,000 schools. Okay, let me copy the completed cumulative frequency graph. Okay, so here's the graph, and we've used the required scale. 2 centimeter is 100 pupils, so we start from zero point 0.5, and then 2 centimeter is 100.5, another 2 centimeter is 200.5, another 2 centimeters 300.5, and so on, all the way till 600.5. And on the y-axis, 2 centimeter is 1,000 pupils, so we take this till 5,000. Then you plot all these points 1,000, 200, 150, 800, and 600, 500,000. Similarly, 0 0.5, 0 for the very first point. And then you join all these points using a smooth curve. Remember to label the x-axis, number of pupils in school, and the y-axis, which is the cumulative frequency. Okay. In the next part, it says 80% of schools have more than n pupils. Estimate the value of n. Okay, so 80% of 5,000, because there are total 5,000 schools, that gives us 4,000. And again, it says more than n pupils. So first you will have to subtract this 4,000 from the total value, which is 5,000 minus 4,000 is 1,000. So you substitute that here. You read the corresponding x value when the y value is 1,000. Okay, so that gives us 160. So answer for the first part would be 160. Part 3 is find how many schools have between 201 to 250 pupils. Okay, for that we just need to look at the table. 201 to 250 will be between these, and we will need to subtract 2100 and 1600 to get the number of schools which have pupils between these two values, 250 to 200. So subtract 2100 and 1600, which gives us 500. Okay. Calculate an estimate for the mean number of pupils. For that, we go back to the frequency table. Uh, So we will need to change the cumulative frequency table into the frequency table. I'm going to keep the continuity corrections. Next value will be 200.5 till 350.5, 350.5 till 450.5, and then 450.5 till 600.5. Okay, change the cumulative frequency into simple frequency. So we'll have 200 here, then 800 minus 200, which would be 600 here, then 1600 minus 800, which will be another 800 here. So, hold on, we'll have just a second. Yeah, 200, 600, then 800, then 500, then 2000. Oh, I might have missed something. Let me see. Yeah, I've missed some value. Okay, let me fix this. So we go from 250 to 350.5, 200.5 to 250.5. Sorry. Okay, that was a mistake. Next is 250.5 to 350.5, then 350.5 till 450.5, and then 450.5 to 600.5. And then when you keep subtracting the two frequencies, we'll get after 500, we will be subtracting these two, which will give us 2000, then these two, which will give us 600, then these two, which will give us 300. So let's fill it up. So 2000, 600, 300. Now to find mean, you will find midpoint of these two by adding these two together and dividing it with 2, then times 200 plus midpoint of these two times 600 and so on all the way till the end, divided by total frequency, which is 5000 in this question. Let me copy that working for you. Okay. The answer will come out to be 268 by multiplying each midpoint with the corresponding frequency and finally dividing the entire sum with 5000. In a recent survey, 640 people were asked how about the length of time each week that they spent watching television. The median time was found to be 20 hours. Okay. This will give us a coordinate to be drawn, to be plotted on the cumulative frequency. Median is when we find 50% of this, that would be 320. So The coordinate that we're getting here is 20, comma 320. That's the first point. Okay. Next would be, and lower and upper quartiles were 15 hours and 35 hours. Okay. 15 and 35 are the X values. What about the Y values? For lower quartile, we find 25% of 640, which is going to be 160. For upper quartile, we find 75% of 640, which is going to be 480. The least amount of time that anyone spends is 3 hours. So we're going to do 3, 0. That's going to be the very first point. And the greatest amount was 60 hours. So 60 on the x-axis, and this will be for 640 people. So 640. Okay, now we're going to plot these 4 points, 5 points on our graph, and we will be choosing an appropriate scale. First, let me copy the graph that I've made. Okay, so I plotted all 5 points and then joined them with a smooth curve. After choosing an appropriate scale, let's take a look at the scale. The scale I chose was 2 centimeter is 10 hours, another 2 would be 20, and so on all the way till 60. Remember to label the axis, time in hours, and y-axis is the cumulative frequency. Here, 2 centimeters is 100 units, then 200, 300, 400, all the way till we need to go till 640, which is the highest value on the y-axis. So I just went till 700. Okay, then you plot these 5 points, join them with the smooth curve, and you have your cumulative frequency diagram as shown. After that, you'll use your graph to estimate how many people watched more than 50 hours of television. Okay, again, it says more than. So what you do is you first read this 50 hours on the graph, which is going to be an X value. So look at this. From 50, we find the Y value, which is coming out to be, for me, it's coming out to be 580. But since the question says more, you're going to subtract it from your highest Y value on the graph, which is this 640. So we do 640 minus 580, which is giving me around 60. So according to your graph, you will give your answer. The marking scheme usually has a small range that your answer must lie in. Mathematics and English A-level marks for 1400 pupils, all taking the same examination, are shown in the cumulative frequency graph below. Both examinations are marked out of 100. Okay. So we can see 2 cumulative frequency diagrams for both English and math. Use the suitable data for these graphs to compare the central tendency and the spread. Okay, you need to know what is central tendency and what is spread. Central tendency means comparison of their mean, yeah, their average, comparison of their average. So the only average we can find from a cumulative frequency is the median. So we're going to compare the median of both of them. And spread is the interquartile range or even the range, but a better range is interquartile range. So we're going to compare the interquartile range for both English and mathematics and median for both English and mathematics to make a comparison of central tendencies, which are the medians of both of these graphs, and the spread, which is the interquartile range, preferably, or it could also be the range. Okay, so let's start by looking at the median scores for both of these tests. Okay, median is at 50%. The highest value on our graph is 1400. Halfway is 700. So the median for math is this value, which is around Let me read that properly. So it is around 50, 57. Looks like 57 to me. So median for math is, first of all, I'm going to write central tendency. So for central tendency, math has a median of, what was that, 57? And median for English would be, oh, did I read the wrong values? Wait, I was supposed to read at 700. I may have not, yeah, this is 700, never mind, which is, this is exactly between 50 and 60, so it's actually 55 if I'm reading it wrong. Okay, so it's 55. And for English, again we find, oh my God, I'm so sorry. I was reading for English first. I'm so sorry. This was the graph for English. So median score for English is 55. And for math, median math score would be, we read this, which is a little less than 40, if I'm reading it right, or almost 40. Yeah, almost 40. So on average, students perform better in English as compared to math, as shown by a higher median English score. So you need to make a concluding statement, which is what I just said, that we can see that the median for English is greater, showing that on average students performed better in English. Okay. Now we have to compare the spreads. Spread is compared by comparing the interquartile ranges. So spread would be the interquartile range. Even range would work, but we prefer interquartile range. Okay, what is interquartile range? Upper quartile minus lower quartile. Let's do that for math first. Upper quartile is found at 3/4 of the highest y value, which is 1400. So 3/4 of 1400 is 1050. That will give us the upper quartile. Okay, let's see, where is 1050? So 1050 will be right in between. Okay, I'm gonna take this here, and that is around giving us an upper quartile of 80. So interquartile range is upper quartile minus lower quartile. We're doing that for math first. So upper quartile is 80. For lower quartile, we first find 1/4 of the highest y value, which is 1/4 of 1400, which is 350. Now read the x value corresponding to 350. 350 is here, and we are reading for math. It's going to be this, which is around what, 12? Yeah. So minus 12, we get a 68 interquartile range for math. Now we're going to do the same for English. For English, it will be upper quartile minus lower quartile. What's the upper quartile for English? Highest value for English graph is also 1400. So 75% of that, or 3/4 of that, is also 1050. So we read the x value corresponding to 1050 looks like 62. So upper quartile for English is 62. Now let's read the lower quartile. Lower quartile will be found at 350. So go to 350 and read the corresponding X value, which looks like 42. Subtract 42, we get a 20. So the interquartile range for English is 20 and the interquartile range for math is 68. Now we need to make a concluding statement regarding this. Interquartile range shows the measure of spread. Greater spread means more variation in the marks. So you can say greater interquartile range for math shows that students' marks were more varied in math as compared to in English. Okay. Second part is state an advantage and disadvantage of cumulative frequency. Now, if you go to the drive link, there's a file there's a worksheet 1E in statistics folder, which has comparison of all of the statistical diagrams in our syllabus. You'll find this comment there. We're going to go over that. An advantage and disadvantage of cumulative frequency graph. Advantage is that we can quickly find medians and interquartile range through the cumulative frequency graph. But a disadvantage is that if you need to convert the cumulative frequency table back into the frequency table, which we've been doing now and then in this worksheet, then that's a tedious task. So disadvantage is difficult to compare frequencies between each data group. That is difficult to construct a frequency table from cumulative frequency graph. And the advantage is that we can quickly find medians and quartiles in a cumulative frequency graph. The following cumulative frequency table shows the examination marks for 300 candidates in country A and 300 candidates in country B. Without drawing a graph, show that the median for country B is higher than the median for country A. Okay, so for median, just a second, please. All right, sorry, I had to go somewhere. Without drawing a graph, show that the median for country B is higher than the median for country A. Okay, so median is found at 50% of the highest Y value. So the highest Y value in both these graphs is 300. So median will be read at 150. So at 150, you'll read the corresponding X value. This would be the median. So let's look where we can find 150 in both cumulative frequency A and cumulative frequency B. Okay, so these are the first 25 values, then the next 68 values. That's not in total 150. Where will we get 150? 150 will be somewhere less than these 159 values, but somewhere more than these 68 values. So that will be between this range. So the marks or the median marks for A would be somewhere between 20 to 35. I'm going to write median A is something between 20 to 35. This value would be something between 20 to 35. Okay, now let's do the same for country B. For country B, we need to find a cumulative frequency of 150, which will be, this is 10, next is 46 combined, then 72, this is 144. So 150 is more than this, but less than this. That means the median would be somewhere between 50 and 70. So median for B would be between 50 and 70. Hence, we've shown that B has higher median. Hence, B will have higher median. Okay, that is done. Part 2, find the number of candidates in country A who scored between 20 and 34 marks inclusive. Okay, they're only talking about country A who scored between 20 and 34. So find the number of candidates in country A who scored between 20 and 34 marks exclusive. So 20 to 34 would be, there are four, sorry, we're talking about country, cumulative frequency A. So there are 68 such pupils who score less than 20 marks, and then 159 pupils who score less than 135 marks. So how many score between 20 and less than 35, which is, by the way, 34? So how many score between 20 and 34? That will be the difference of these two. So for part 2, we do 159 minus 68, which would give us 91. In the next part, we have to estimate the mean marks for candidates in country A. Okay. For mean, we will first need to change this cumulative frequency table into a frequency table. Since they're talking about marks, the minimum marks somebody can obtain is 0. And if we look at this, this says less than 10, so we can go from 0 to 9, and the frequency is 25. That is 25 students score between 0 to 9 marks. And remember, marks are discrete. So the next mark would be 10. You get marks as a whole number. You do not get marks in decimals, especially in Cambridge checking. Okay, so next we'll go from 10 to, it says less than 20, so 19. Then we'll go from 20 to 34, then 35 till 49, then 50 till 69, and then 70 till, this is going to be 99. Okay, let's write all the frequencies underneath these ranges. So this is the first one is 25. Next would be 68 minus the previous value 25, which will give us 43. For 20 to 20, uh, for 20 to 34, we're going to subtract 159 and 68, which gives us 91. Similarly, we'll have a 75, we'll have a 26, and we'll have a 40. Okay. Now we're ready to find the median. For that, sorry, to find the mean. To estimate the mean, we find mid value of this, which is 4.5, times it with the frequency, plus mid value of this, which is going to be 14.5, plus mid value of these, which is going to be 27. Similarly, you do that for all the way till the last value, which will be a mid value of 70, and 99 would be 84.5 times the frequency divided by total frequency. Total frequency in this question is 300. And this will give us a rounded answer of 37.6.